This section is simply the word square root. Square root. Okay, a square root is a number multiplied by itself to form a product. A number multiplied by itself to form a product. That product is called the square root. Okay, so for example, we know that 4 times 4 is 16, right? Or 4 squared is 16. So that means that the square root of 16 is what? 4. Because when you're finding the square root of a number, you're asking yourself what number times itself is equal to this number. So the only number times itself that equals 16 is 4. So the square root of 16 is 4. So 16 is what's called a perfect square. Not all numbers are perfect squares. Only certain numbers are perfect squares. A perfect square is a number whose positive square root is a whole number. So again, not every number is a perfect square. Not every number has a whole number square root. Only certain numbers are called perfect squares, that when you take the square root, you'll get a whole number. So, for example, 1 is a perfect square because the square root of 1 is what? 1. Can anyone think of what the next perfect square is? Okay, 9 is 1, but there's 1 in between 1 and 9. 4. The square root of 4 is 2. The next one would be 9. The square root of 9 is 3. Okay, and we can keep on going. Next would be 16, then 25, then 36. You're just doing 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. So there's only certain numbers that are perfect squares. So when a number is a perfect square, finding the square root is very simple. You're just asking yourself what number times itself gets this product. For example, the square root of 49. When you're trying to figure out the square root of 49, you need to ask yourself what number multiplied by itself is 49. 7. Okay, if on your homework you get to a problem where you don't know what number times itself is that number, all you have to do is start testing numbers. Okay, for example, if you had the square root of 169. Okay, maybe you know that 10 times 10 is 100. You know that 11 times 11 is 121. You know that 12 times 12 is 144. So maybe we should try 13 times 13. Is 13 times 13 169? So the square root is 13. You're also going to see some problems that look like this, negative square root of 25. So it's important to understand this is not saying what is the square root of negative 25 because the negative is outside the square root symbol. So you do this problem in the exact same way. The only difference is it's like multiplying negative 1 times the square root of negative 25. Times the square root of 25. So the square root of 25 is 5 times negative 1 would be negative 5. So don't let that negative sign throw you off. You just throw it in front of your answer. Okay, you're also going to see some numbers where some questions where you have to compare square roots. For example, the square root of 88 compared to 9. And when I say compare, I mean give it greater than, less than, or equal to. So, is 88 a perfect square? No. If you were to type the square root of 88 and on your calculator, you're going to get a decimal with lots of numbers, okay? A repeating decimal. But you don't need to use your calculator on this. You're going to compare these by estimating. So we know that 88 is not a perfect square, but we should also know a perfect square that's close to 88. What would be a perfect square that's close to 88? 81, right. The square root of 81 is what? 9. Okay, so if the square root of 81 is 9, then is the square root of 88 going to be greater than or less than 9? Greater than, because it's a bigger number. So we know the square root of 88 is greater than 9. Here's another example. The square root of, 7 compared to the square root of 63. So again, 63 is not a perfect square. But we can estimate the square root of 63 by using a perfect square that's very close to 63. Which perfect square is very close to 63? 64 is a perfect square, and the perfect square of 64 is what? 8. Now, the square root of 63 is going to be a little bit less than 8. But do you think it's going to be greater than or less than 7? Greater than. If you think about it, 7 times 7 is what? 49. So we know the number must be greater than 7 to get a product of 63. No, because, oh yeah, I did. I'm sorry. Thank you. 7 is less than 60. Square root of 63. Thank you. Okay. So that's pretty much all you need to know about square roots. You're going to cut out each box, but do you see, look up here really quickly, do you see how at the top of each box you have this blank space? Okay, do not cut that off. You need to cut around so that at each box at the bottom has the shaded part and at the top has the blank part. Okay? So just go ahead and cut out each box. You do not need the part that says properties of real numbers. And if you'll collect your trash in the middle of the table, I'll come pick that up from you guys. So each box should look like this. No, you don't need that. Just the 6 boxes. real numbers like you see on the screen. So what we are learning today is how to categorize numbers in the real number system. So all the numbers that you will see today are real numbers. This is the most broad category. So all you need to do on the front of where it says real numbers, you're going to write the definition of a real number, which is simply any number that can be represented on the number line. This is any number that can be represented on the number line. So on your homework tonight, when you're classifying numbers, you are not going to use real numbers. All the numbers you see tonight are real numbers. So this is not a word you're going to use to classify the numbers. This is just basically the umbrella which all these other classifications fall under. So let me show you how to glue. You're going to glue this in. You're going to go to page 10, so flip to the next page. And look up here before you do it. This blank part right here, you're going to fold down. And you're going to put just a tiny amount of glue on that flap. If you put too much, wipe it off with your finger. It's going to be a big mess. Then you're going to glue that at the top of page 10. So the only part that should have glue on it is that folded part. You're just going to glue it at the top of page 10 so that it can flip up and down like that. If you have questions about how to do that, please let me know before you glue. Okay, the next square you're going to find is the one that says natural numbers at the bottom. Okay, so on the front of natural numbers, we're going to write some examples of natural numbers, and then on the back, we're going to write the definition. So you can go ahead and fold this part down so you know not to write on that part, because that part's going to have glue on it. Not yet, but when we're done writing on it. Okay. So, natural numbers. I'm going to write some examples of the natural numbers on the front, and then we're going to decide on a definition. So, here's some examples of natural numbers. 1, 2, 3, 4, and so on. That would continue with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So, what do you notice about natural numbers? They are positive, yes. What else? They're whole numbers, yes. You don't see any fractions or equivalent decimals. What else? What number did I start with? 1. I did not start with 0. I started with none. 1. So if you'll flip this over to the back, let's write the definition. Natural numbers are the counting numbers. Natural numbers are the numbers you would use to count. So think about it. When you're counting something, you don't start with 0. You start with 1. If there was 0, you wouldn't need to count it. Yes? Yeah, so I took it like this, and then I just flipped it like that. Yeah. Okay, so we know that 0, negative numbers, and fractions are not included. 0, negative numbers, and fractions are not included. So natural numbers are simply the numbers you would use to count with. If I was counting the students in here, I would say 1, 2, 3, 4, 5, 6, 7, 8, and so on. So once you're done writing that, just like you did last time, watch up here before you do this, guys. You're going to put just a tiny bit of glue on the folded part just like you did last time, okay? You're going to flip up the real numbers tab, and you're going to glue this directly under, as close as you can get it, to the real numbers tab, so that when you fold the real numbers tab back down, you can see both shaded parts. Okay, once you have that one glued down, take out the square that says whole numbers. So again, on the front, we're going to write examples of whole numbers first. Some examples of whole numbers are 0, 1, 2, 3, 4, and so on. So what do you notice about these numbers? Again, we still see no fractions or decimals. What else? This time, good. This time I'm starting with 0 instead of starting with 1. Do we see any negative numbers? No. So if you'll flip over again to the back side, whole numbers are basically the natural numbers. And 0. So basically the only number that's a whole number and not a natural number is 0. That's basically the difference between the two. Whole numbers include 0. But still, fractions and negative numbers are not included. So basically, if it's a natural number, it is also a whole number unless it's 0. If it's 0, it's only a whole number and not a natural number. You're going to glue this on in the exact same way. Put a tiny bit of glue on the folded part. Lift up your natural numbers tab and glue this one directly under it so that there's no space between the two. Do you need to see the definition again? Okay, the next square we're going to use is the one that says integers. So an example of integers, some examples of integers look like this: -3, -2, -1, 0, 1, 2, and 3. And they continue both ways. So what do we notice about integers? Yes, now we are seeing both negative and positive numbers. What else do we notice? We're still not seeing any fractions or decimals. Good. So on the back, flip that over to the back, and the definition of integers. Integers are whole numbers and their opposites. So basically we're looking at now all the numbers that were whole numbers plus all of the opposites. So all the negative numbers as well as all the positive numbers. Fractions are still not included. Fractions, negative or positive, are not integers. When you're done with that, glue it on in the exact same way. Okay, the next box we're going to use is rational numbers. So here's some examples of rational numbers. So what do we notice about those rational numbers? Yes, we now see fractions as well as decimals. What else? There's negative and positive. Yes. Do you see any whole numbers? Yes. Do you see any integers? Yes. There's a whole number disguised as a fraction up here. Which one is it? 7 over 1. And the integer is negative 6. Okay, so let's flip over and write what our definition of rational numbers are. Rational numbers. A number is rational if it can be expressed in the form A divided by B, where A and B are both integers and B does not equal 0. So basically, a number is rational if it can be written as a ratio. Notice rational has the word ratio in it. We should remember that ratio is basically another word for a fraction. You have two numbers written as a fraction. So any number is rational if it can be written as a ratio. Then a whole number 8 can be written as the ratio 8 over 1, or 8 divided by 1. The decimal 0.25 can be written as what? Fraction. 1/4. Yes. The only time that decimals are not rational is when they are repeating without a pattern, so you cannot write them as a fraction.
Wait, why did you say B?
Okay, B cannot be equal to 0 because remember those properties of 0 that we talked about, you can't divide a number by 0. So that's why the number on the bottom can't be 0. So go ahead and glue this in. And get your last box, which is irrational numbers. Here's some examples of irrational numbers. So for those examples, we see pi, the square root of 11, and the square root of 2. Anybody have any guesses on why those are irrational? Right, exactly. Irrational numbers. If rational numbers are numbers that can be expressed as a ratio, then what do you think irrational numbers are? Right, numbers that cannot be expressed as a ratio. So numbers that cannot be expressed as a ratio are numbers that have decimals that do not end and that do not have a pattern. So let's write that definition. Irrational numbers cannot be written in the form A divided by B. They include square roots of non-perfect squares and non-terminating decimals. So non-terminating decimals are decimals that don't ever stop and they have no pattern. So it's important to understand the difference between non-terminating decimals and repeating decimals. Repeating decimals are decimals that don't stop but they do have a pattern. For example, 0.33 repeating or 0.16 repeating, where it's the same two numbers repeating over and over. That's different than a non-repeating number that has a bunch of numbers with no pattern that never stops. Glue that last one on and then let's do some examples. So this section of your homework is going to say, write all classifications that apply to each number. So each question doesn't necessarily just have one classification because it might be more than one thing. So it's important that you go through each of the 6 classifications and decide all of the ones that fit to that number. So for example, if you had the numbers 7 and 4/9, and again, the instructions say, write all classifications that apply to each number. So what I would do if I were you is I would just go through them one by one. Is this a natural number? No. You would not use this number to count. I wouldn't say there's 1, 2, 3, 4, 5, 6, 7, 7 and 4/9, 8 students in this class. It's not a natural number that you would count with, so it's not a natural number. What about whole number? No, why not? Because of the fraction. What about an integer? No, again, because of the fraction. What about a rational number? Yes. Now, can it be rational and irrational at the same time? No. So once I know it's rational, I'm done. Right, it's a real number, but you don't need to write real number every time because they're all going to be real numbers. Okay? So all of these numbers are real numbers. So don't feel like you have to write that every single time. Okay, how about this one? I'll let you wait till you get to upper level math and they can tell you all about non-real numbers. Imaginary numbers, yes. Okay, -12. Let's see. Is it a natural number? No, because it's negative. Is it a whole number? No, again, because it's negative. Is it an integer? Yes. Is it rational? Yes. Okay, last one. Square root of 10. Square root of 10. Now, what you want to ask yourself when you see the square root sign, just because you see the square root sign, don't automatically jump and assume that it's irrational. What you want to do is just check and see, is that number a perfect square or not? No, 10 is not a perfect square. So now that I know it's not a perfect square, I know that it's what type of number? Irrational. Now, if it was a perfect square, let's say that said the square root of 9. That means that you're really classifying what number? 3. Okay, so if it's a square root of a perfect square, make sure you're classifying the square root, not the, or so you're classifying the square root of that number, not the original.
So if something was like 3, you have to put natural and the whole number is irrational.
Yeah. Right, exactly. If it's irrational, it's not going to be any of the other ones. It's just going to be irrational. So you're never going to see an irrational number that's also a whole number, also an integer. Any other questions? Okay.